Okay, thanks a lot, Al. So my talk tonight is, again, sensitive to water resources in Colorado. And I think this is a nice discussion for us to have in this forum. And the reason is, so much of what we want to talk about in Colorado when it comes to water comes along with a lot of discussion on how water is developed in Colorado over the years. And we have to start with the basic hydrology of water in Colorado. So again, I'm from the State Engineer's Office. That's also the Division of Water Resources. We're a statewide agency, and we do the work of administering the water use in Colorado. So if you think of the naturally occurring water in streams and reservoirs, and the water in the ground, and water users want to use that, whether it's the municipal provider or the farmer or the domestic well. They all have the need to use that water that's naturally occurring. And that's all done according to a system of water rights in Colorado. You really need to have a basic understanding of it. So I'm going to talk about that. I need to just ask folks real quick, because up here I hear myself with a little delay or echo. Are you all able to understand me okay? Okay, very good. Thanks. So this is going to be, again, the Citizens Guide, just to give us a basic understanding. To start that off, we need to talk about Colorado's hydrology. And if you look up there, we've got a nice map of Colorado. It's not showing the cities, it's not showing the population centers, it's not showing the counties or the highways. It's just basic Colorado topography and hydrology. And that's a good way to start, because if you look at that, we've got running down the center, generally the center of Colorado from north to south, we've got a range of mountains, and mountains to the west and the southwest corner. So that's a very prominent feature. And what that prominent feature does hydrologically and climatologically is it gathers snow in the winter. Now, so far, we say we know about the snow in the mountains. But think about how significant that is for Colorado's water. That happens somewhat in the center of the state. And then when springtime comes and the snow melts, it runs off in all directions out of the state. There's the ways to really fully utilize water in the state and the ways to allocate it. So now let's move on to complicating factors. What I'm going to talk about in this part, this second part, is just the need to share water with other states. And then we're going to talk about droughts. And notice that's plural, not just one drought, multiple droughts. Talk about groundwater use as a solution to drought, for one thing, in the way of irrigating more areas. And we're going to talk about how groundwater then was incorporated into surface water administration. That's a tricky one. And then we'll talk about developing needs later on in the 20th century. And then again, we'll talk about drought. So the first complicating factor. So here's a quote. All I really needed to know, I learned in kindergarten. Heard that before, right? And the first one on that list, the first thing you need to know that you learn in kindergarten is to share. And I know this is true because I looked it up on the internet, and right, everything on the internet is true. So it must be true. Well, what does that have to do with Colorado water? Well, in Colorado, we have to share our water with the downstream states. So a while ago, I was talking about how great it was to be a headwater state. All of our water develops and originates in Colorado. We can use it in the state, and that sort of sounded like we can do whatever we want with it. But that's not true. In Colorado, we have one international treaty with Mexico. We have 9 interstate compacts and 2 U.S. Supreme Court decrees. And all of these are about how Colorado needs to share. They need to save some of their water and allow it to be delivered to the downstream states. 2/3 of Colorado's surface water obligated to downstream states. So here's a list of our 9 interstate compacts. I'm not going to go through them one by one, but you see the Colorado River Compact.
You see the Arkansas River Compact, the Rio Grande Compact, South Platte. All of these operate in a different way. They may operate on the amount of water that's being delivered at the state line. They may operate on marking a point in time and saying, okay, Colorado, whatever you were using at this point in time, you can't develop anymore. There are several different ways. Matter of fact, there's about 9 different ways you see on this list. But they all have to do with sharing water with the downstream states. And that happens at a federal level, by the way. So here's a nice graphic. If you see the states in the beige color, those are 19 states that rely on Colorado water. That's pretty extensive. If you look at it, it goes out to Kentucky and Tennessee. Now, and by the way, I'm not suggesting that if you catch water off your downspout and collect rainwater that you cause a drought in Tennessee, but it's interesting that it extends so far, Colorado water. So let's move on to droughts. Here's something I got off the NRCS, National Resource Conservation Service website, and they update this map regularly, and it's very graphic. You don't need much explanation because it's so self-explanatory with the colors. And if you look in the southeast part of Colorado, where it's darkest brown, reddish and darkest brown, that's the drought we have going on right now. And we wish we could say that this snow came along and remedied all that, but it hasn't happened. And again, if you look in southeast Colorado, Texas and Oklahoma, Panhandle, Kansas, a little bit into Nebraska, that's, by the way, where the big Dust Bowl drought, the occurrence of drought in the 1930s was going on. Just the exact same location. So this isn't something that just happens once in a lifetime. We have a cycle of droughts in Colorado. When we have a drought, then suddenly we have a need to manage what was kind of a scarce resource before and is now a very scarce resource. It tests our prior appropriation system, our priority system, right? Because that tells us who gets to use water before somebody else gets to use water. So when there's a shortage, that becomes even more sensitive. It also helped us develop and understand a process for changing water rights. So if we've got a drought, maybe we would like someone else to use our water, but you just can't give your water to someone else. There's a legal change process. So that's kind of what drought has led to our administrative process in Colorado. But also, it suggested maybe we need a drought-proof source of water. Well, we're a headwaters state. There aren't too many other options. Does anybody have an idea what a drought-proof source of water might be in Colorado? Any thoughts?
Aquifer.
You pointed down. Yeah, underground. Because that gets in the ground and it moves more slowly. It doesn't exit the state like in a couple days, like surface water does. So, we need to talk about increased groundwater development in Colorado as our next complicating factor. Groundwater development in the state. In the 1930s, I just talked about the Dust Bowl, the big drought. But along with that drought came rural electrification. And so this was two good things coming together. We need some other source of water. And now all of a sudden, in the remote rural areas, we've got electricity. Because while the groundwater is great, without a means to pull it out of the ground, it's not really helping us much, right? So that allowed widespread well development, especially in eastern Colorado, the Arkansas and the South Platte River basins. Then in the 1940s and 1950s, we just had continued well development. It was going good. Not only did we have a drought-proof source of water, but actually we had a source of water in more remote areas. So while the ditches and canals opened up lands to irrigation, the wells opened up even more land to irrigation. The 1960s, though, there was a hint of a problem. Actually, that hint of a problem started in the 1920s and 30s, but it really came to a head in the 1960s when the surface water users said, wait just a minute. That water that you are taking out of the ground, we think that water was actually on its way to the river. So if you take the water out of the ground, it doesn't get to the river flow is diminished, we're not getting the water we're used to. We think you need to abide by the prior appropriation system just like everyone else. Well, that was a difficult, gradual process. And in the 1960s, there was well permitting for the first time. There was an evaluation of well permits, and the state engineer had the authority to deny well permits. And we were administering wells. But we didn't quite know how to do it because water's underground and it doesn't flow that fast to the river. Finally, in the 1970s, the law came down and said, if you're going to pump water from a well, you've got to determine your impact on the river, and you're going to have to put water in to make up for that. That was called augmentation. So that happened in the 1970s, and that right there, that was the bottom falling out. That was the well owners saying, we got a problem. And some of them were saying, no, we don't have a problem. You surface water users have a problem. So there was a lot of water court activity where this was being fought out. But eventually, in the 1970s, these augmentation plans took hold. And they were operating. There were plans to replace water in the river. And it was working. And so for the 70s through the 1990s, we had prevalent groundwater use, and it was working. Everybody was pretty much satisfied. Then in the year 2000, or 2001 actually, beginning in 2001, we suddenly had stricter administration. There was a Supreme Court ruling that caused that to happen. We don't have time to talk about this tonight. But suddenly there was stricter administration. Well, the bottom fell out again, especially here in the Arkansas River Basin and the South Platte River Basin. But over the last 10 years, these well users have done a good job of dealing with both the augmentation requirement that started in the 70s and the strict administration that had started about 10 or 12 years ago, 13 years ago. So they're operating pretty well. But I just think we need to spend a little time talking about why this whole groundwater thing is so difficult. And this is probably the second thing I'd really like, if you all went home tonight and said, I remember two things that guy from the state engineer's office talked about. First, remembers the prior appropriation system, and second is why these wells fit into that process in such a difficult way. So we incorporate the groundwater use into the prior appropriation system. The groundwater rights are relatively junior, so you would say they should never be able to pump. What makes that so difficult is that effect on pumping is lag. The farther you are from the river, the longer it takes to actually hit the river. So we don't really know what the situation is going to be 2 months from now when our well's pumping effect actually hits the river. We could also talk about non-tributary groundwater or not non-tributary groundwater, but I don't want to do that, so that just went out off the side of the screen. So here's our discussion on well pumping effect on surface water. And this is the second thing I want you to really remember from tonight. So let's look at a cross-section. We've cut away a part of the earth, and we see the ground surface, and in our cutaway we see the groundwater table surface. And then we see the saturated alluvial material, the saturated ground, and we see a confining layer, something on the bottom that keeps water from flowing through it. So as we look at that groundwater table. See how it slopes up? We've got a constant discharge of that groundwater to the stream due to the fact that that groundwater surface is at a higher level than the stream surface. Flow occurs due to this hydraulic gradient, which is another word for gravity, right? And it increases or decreases with the magnitude of that hydraulic gradient. So that's the discharge. See the size of that arrow? We've got a fair amount of water discharging to the stream. Well, if there were no other hydrologic influences, that constant discharge would cause the water table to gradually go down. And look, it would be at the same level as the stream, right? We've got nice equilibrium. That's what the world likes. That's what nature likes, is equilibrium. So once we hit that equilibrium, there's no more groundwater discharging to the stream. But we've got influences like precipitation recharge. We've got ditch, pond, and reservoir seepage. And we've got deep percolation from irrigation. So the result of that is that that water table stays at a higher level and is constantly discharging to the stream, constantly receiving new water from these other influences. Now, it might fluctuate a little bit from year to year, but the groundwater discharge continues. So we've got that still equilibrium, but a dynamic equilibrium. And that keeps everybody happy. So again, we're good until somebody comes and puts in that irrigation well. You want to understand why this well has trouble reconciling with the prior filtration system. Well, that well starts pumping, and it creates an immediate effect on the water table, but it's kind of limited, right? Because it just started pumping yesterday. But as that pumping continues, that effect is greater, both in the magnitude and areal extent. So we're having a bigger effect on that aquifer. At the end of the season, the pumping from the well stops, and the aquifer starts to recover near the well. So we're starting to get back to equilibrium. But let's face it, some water was taken out of the ground. Something's missing. So we've got a little hole in the groundwater, and that depletive effect remains, and it slowly works its way toward the river. So our nice hydraulic gradient has been upset. Since the aquifer is depleted from what it had been before, we've suddenly got a situation. Look at the water table is lower than it was. What's that going to do to the groundwater discharge? Right? Groundwater discharge is going to suddenly diminish because that hydraulic gradient is lower. So we've got less water discharging to the stream, and we point to the well, and the surface water users say, see, the well caused that. Now, it's not so exaggerated, not so obvious as I just made it, but we know it happens. So when that well pumping creates a depletion that impacts the stream, we call that the depletion. And if the stream is over-appropriated, if there are water rights that are wanting water, then it's called material injury. And that's a problem with the prior appropriation system. So that points to why the surface water users point to the groundwater users and say, you're injuring the stream, come into the prior appropriation system, replace what you depleted. So that's the second thing I really want you to remember tonight, how that groundwater development impacts surface water rights and how that's a problem in the prior appropriation system. So, groundwater development, priority administration, groundwater rights are relatively junior, got that lag effect of pumping. So if you're using groundwater, for the most part, you're going to end up with a nice resource, but it's got an inherent obligation to the stream. There's going to be legal costs, and engineering costs, and accounting and administration efforts. So, in addition to those other complicating factors, there are some other things we need to consider. Today, concerns over climate change, population increase, changing water demands. 100 years ago, it was largely agriculture. Now there's more water demands. Efforts to preserve agriculture. We don't want to take it all out of production just so we can serve all the municipalities. There are energy needs. We're going to be talking about that. There's tourism. Then there's tighter administration. Remember I talked about in 2000 when the bottom fell out. So those are complicating factors. And that's why when I started out wanting to talk about Colorado's basic hydrology and these certain relevant issues for today, we quickly got everything obliterated by this history of water development